Hello everyone, welcome back. In this episode, we will cover a cornerstone of programming, and that is if statements. A really important tool, let's get into it. Don't forget this channel have a dedicated Discord server. It's a place where you can talk about the episodes and tutorials of this channel. Maybe you wonder something about the last episode that was a bit unclear. Or maybe you just want to say hello. And for those who wish to go the extra mile to support the channel, there's a link to my Buy Me a Coffee page, and also there's a membership option here on YouTube. Thank you. In most coding languages, we can check to see if something is true or if something is false. Depending on that check, we can execute different types of code. Let's take an example from a game. A player is trying to open a locked door. Here we'll have a check. If the player have the key, the door opens. Otherwise, the door remains locked. And this is how it's going to look in code. First, we're typing out if, and that indicates we're trying to check something, if something is true or if something is false. And here we're checking if the boolean have key is equal to true. And if that statement is true, then we enter the code block for that statement, which is this line of code. If this turns out to be false, then we enter this one, because we have the else. If this is true, do this. Else, do this. So let's see here. Have key is a boolean and it's false. The player does not have the key, so we shouldn't enter this one. So we should enter the else bracket here, because if we do not have the key, do this instead. So let's run it and see what happens. Player does not have the key, the door remains closed. And inside here, we're not setting have key to true. We are setting the value with 1, we're checking if something is equal. Have key is false. False equals true, well, that's false. But true equals true, we're checking if two sides are the same. Just like you can do in math, where you have one equation on one side and numbers on the other side, and you have an equal sign in between. Both of those sides are the same. And the same goes here, but here we're going to check whether or not that is true. And in this case, have key is false, so this isn't true, therefore we enter this one. But if we change here to player having the key, so now the player have the key, we should now enter this one. And the player got the key, so the door opens. But what if the player does not have the key, but he does have superpowers? We can't check for that. Well, we can by going else if, another parentheses, and another code block. And here we can check if the player have superpowers, true. Now we can add some line of code here. Player opens the door with superpowers. When we run this now, first we're going to check if we have the key, which we don't, or the player does not have. Then we check, well, what about this statement right here? We have an else if this is true, which it will be, so we should execute this line of code. And because one of these code blocks now were true, then we ignore everything else, no matter how many else if there is or else what we have. We're just gonna move to the end of this entire if statement and continue the code lines down here. So for example, let's copy this, put it at the bottom here, and just say hello. So let's run it and see what we get. Player opens the door with superpowers. That's because this one was not true, this one was true. So we executed this line, we ignored the else because we didn't need to go in there, and then we were at the end, so we continue the code execution below it. Of course, you can have as many else ifs as you want, so let's add another one, else if, like so, and we can see can pick locks equals true. Then we copy one of these again. Player opens the door with lockpick. So we set superpowers to false, and we run this again. Player opens the door with lockpick. because that one was true. But what if this one was true then? Have key true. This one is true, and this one will return true. And we can put this one true as well. So all of these will be true. But when we run this, player got key, door opens, because that's the first thing we checked. Doesn't matter how many else if we have, if they are true or false, as soon as we enter one code bracket, we're gonna ignore the rest. And if all of these are false, then we run it again. Player does not have the key, door remains closed. And that's part of this line. And that's because we have an else. Else is the bracket that takes and runs the execution of code if everything else fails. But if statements does not need a else. We can run this, and we just have hello. We tried to see if we had the key. We didn't have the key. We didn't have the superpower, and we couldn't pick lock either. Well, everything was false. There's no else statement, so we do nothing. You can build your if statements however you want, but you need to begin with an if, and if there's an else if, that always comes after, and if you want to use an else, that is always at the end. We cannot have it like this. I'm just going to copy one of these. And this will of course fail, because else if is supposed to be before the else. Else is only used in the end, if is only used at the beginning, but else if can be in between them. And when it comes to if statements, right now we're just checking if something is true. We can also check if something is false. If have key equals false, then we say player does not have the key, door stays closed. Now this is a pretty useless check, but just to demonstrate that if have key is equal to false, false equals false, that's a true statement. Player does not have the key, door stays closed, which is this one. We can also, if we do true again, and instead of checking if it's equal, we can also check if it's not equal. I'm gonna put them here actually. And I think that is all of them. There should be 6, yes, that's correct. Now, these ones is only used when it comes to numbers, just like math. Is 4 more than 3 and so on. But right now we can only use these ones when it comes to booleans, so we're gonna stick with them. But those are the ones we're gonna check soon. So have key is not equal to true. False is not equal to true. That's a true statement. So player does not have the key, door remains closed. So false is not equal to true. Player does not have the key, door stays closed, because have key was false. So we do enter this one. Let's remove this for now, just to make it easier to see. When you're checking for something in a statement here, you can also keep checking for other things in the same statement. So let's make it easy first. If have key is equal to false, so if have key is false, and is what this means, and superpowers equals to false, and we can keep on checking 2 of them, can pick locks not equal to true. So let's see here, it should be false. Yes, that's one false, so this one turns true. Then we have another one we're checking. Is this true? Superpowers equals to false. Yep, that's gonna be true as well, because false equals false. And then we have can pick the locks, and that cannot be true. Can pick locks equals false. Absolutely, so we enter this bracket. But if one of those fail or is false, so let's say this one, we change to can pick lock equals true, is pick lock true. It's false. So this one will return true, this one will be true, and this one will be false. And all of them needs to be true, which this is not. So we don't get that printout. We don't get this execution of code. So here we have an example of a nested if statement. And I'm only using ifs here, but for example, this one could continue with else else if, and so on and so on. And you can see that it's dented, it's tabbed in. So this one, or rather this one, is connected with this one. Can be a bit difficult to read sometimes, and that's why you don't really use it like this, but I'm just showing that you can do it like this. You can put another ifs inside another ifs inside another ifs and so on. But just to make it easier on us right now, I'm just gonna stick with the normal one. But the same rules apply. And here we are first doing a check if the player have the key. Then we enter this code block, which is all the way down here. This code block in blue. And inside here we have a printout. Then we have another ifs. If superpowers is equal to true, then we enter this code block all the way down there. And we have a printout inside here, and then we have another if statement. And if that's the case, then we enter this code block right here. So if I run this, let's just check what we have. We have false, let's go true and false. So if I run this, let's take this one up a little bit. Player have the key, door opens, perfect. Player have the superpowers, perfect. And then we check if this is true, which is not, so we don't enter this. We would have entered another else here, if that was the case, because this else belongs to this if. But we didn't have it. So yeah, you can put ifs inside another ifs, and this isn't the preferred way of doing it, but I'm just showing that it's possible, not the best code practice. That comes way down the road. But yeah, this works. But when we are checking for something to be true or false, having it like this, have key equals true, there's a shorter way of writing it, which makes more sense, because we are just checking if whatever between these two parentheses are true. So we can remove the equals true, and just have the have key boolean. If this boolean is true, then we do this. If this boolean is true, then we do that, and if that boolean is true, then we do that. And if we run it again, we get the same results. And this is much easier to read. And if we want to check if they are not true, if they are false, we just put a exclamation mark before the boolean. So if this is not true, and we can see that because of the exclamation mark, then we run it, and we don't enter it at all. Because we're checking if have key is false, but it's not false, it was true. Therefore, we don't enter this code block at all. So we completely ignore these two ifs, and we go down here. So yeah, and of course the same applies if you have more. We can check if can pick lock, and so on and so on. There is no limit really to how many you can check. It's just preferred to have one check per if. And of course we can check more than just booleans. I talked about these fours: more than, less than, more than or equal to, less than or equal to. Here we have a if statement. First we're checking if A is equal to B, then we print out A is equal to B. Otherwise we're checking if A is bigger than B. If that fails, we're checking if A is less than B. And if all of those fail, something is wrong, because one of these must be true. It's either they are equal to each other, one is bigger than the other. So one of these should be executed. Let's run it and see what happens. A is less than B. A is less than B, which is this one. A less than B, which is true. 5 is less than 11. And of course we can check for more than or equal to. So more than or equal to B is more than B, more than or equal to B. Then we have A is less than or equal to B. A is less than or equal to B. So we can check for two things at the same time here. And if we run it again, A is less than or equal to B, which is true. A is 5, B is 11. And if we set A to 11, and run it again, A is equal to B. That makes sense. But what if we check for A equals B, but here we check for A equals C. C is 100 and we run it again. A is more than or equal to B. A is 11 and B is 11. It's not more than, but it's equal to B. So that's why we entered this bracket. And just because you're checking A here and C here, you can check B here, D here, and so on. Doesn't really matter. It's whatever's inside here that's going to be checked, whether it's true or if it's false. And we can also check if, in the same here, A is equal to B and C is bigger than D. And we run this now. We're gonna get A is equal to B and C is 100 and D is minus 55. So this is true as well as this one. But what if we only need one of them to be true? Then we have another one, which is 2 lines like that. And I'm using a Swedish keyboard. I'm not sure where you find yours, but I find mine at the left side of Z key, between Z and Shift. So these 2 lines is the same as OR. If A equals B or C is bigger than D. So we change A to 10 and then we run it. A is equal to B. We enter this code. So we check here, A equals B, A is 10, B is 11. No, that's false. Okay, but we have an OR, so false, or is this true then? C is bigger than D, 100 and minus 55. So this one is true, this one is false. So we only needed one of them to be true because we have an OR. So that's why we entered this bracket. And of course we can keep checking for something else. And D is less than 0. So is this true or is this true? One of them needs to be true, but this one must be true. A is equal to B. This one fails, this one is true, this one is true. So if this one was false, and we run it again, A is less than or equal to B. We entered this code here. This one was false, this one was true, only one of them needed to be true, and this one has to be true, which it was not. That's why we didn't enter this bracket. So yeah, there's a lot of things you can check for and a lot of ways you can do if and else statements. This is used a couple of ways, and it does not have to be integers, it could be longs, it could be floats, so on and so on. There's no limit to it. But if you do have a lot of checks inside one if like this, I suggest that you add more ifs and then check for one statement at a time. And if that is true, then you move to the next check and the next check and so on. Having everything inside one is very hard to read and it's easy to get stuck and not knowing where you went wrong when you get weird results. And of course, we can check if 2 strings are equal to one another. And there's one thing we need to remember, that string is actually an object, but we treat it as a variable. So if we check if a string is equal to another string, we're not technically checking if the text in the string is equal to the other one. We're checking if they are the same type of instance of an object, which is something I'm not going to get into this early in the tutorial. We're just going to push that forward. So you can check it with an equal sign or not equal like we have done with numbers or booleans, but they can give you the wrong answer. So the correct way of checking if a string is equal to another string is to say string dot equals to or equals and then put the string inside. And if I run this, so right here we're checking if A is equal to B and we have hello is equal to world. No, that's not true. That's false. So this one fails like we suspect it should. Then we have this one, A equal to D. Hello is equal to hello, but here we have a lowercase and here we have an uppercase. This one should also fail, which it did. So we didn't get inside there. Then we have if A is equal to E. A is hello. E is equal to hello. Yeah, that should work. But this is not the right way of checking. And that's because strings are technically an object. So if you want to check if a string has the same text as another string, is by going string dot equals e, or the string you want to check. And then this is the correct way. So down here, I'm going to show it's going to fail. Uncomment that. So here we're checking if A is equal to C, and we have A is hello and C is also hello. It's the same in text, but this one is going to be a different object than this one, even though they have the same text inside. So this one will fail. This says this cannot be true. This will be true. So we're checking A equals C here, and then we're checking if A equals C. And if we run it now, we get these lines here, and then we have this will be true, which is this one. So when it comes to strings, use dot equals and not that way, because this can be false even though you know it's going to be true. So this is just an example. Of course, you can check strings, then you can check booleans, and you can check numbers in the same cluster of if and else, etc. You can check for a lot of different things in a lot of different ways. More than, equal to, is this true, is this false, is this true and that one is false, true or false, and so on and so on. There's a lot of different ways you can check things. So yeah, that was the if, else if, and else in Java. It opened up ways for the programmer, that being you, to execute different parts of your code, depending on some values or booleans that you give it. It's very useful. I hope to see you in the next episode. Take care now and have a wonderful day. Bye.